Welcome, everybody, and hello. On behalf of BMAC and our partners, the National Research Council Industrial Research Assistance Program, I want to thank you for joining us today. My name is Sean DeVries. I'm the Executive Director of the Battery Metals Association of Canada. It's my pleasure to welcome you to our Mining Innovation Showcase series. Today, our topic of focus will be nickel, Canada's energy advantage for the electric revolution. So I'd like to remind everybody, please mute your lines so we can avoid any background noise. Please feel free to use the chat function should you have any questions throughout the presentation, and we'll take some time at the end to address as many of those as we can. Of course, if you require further information or you're looking to connect with one of our participants, they'll have their information available. If you don't get that, you can contact Alexandra or myself, and we will follow up with you. So I want to acknowledge that I'm joining you today from Barrie, Ontario. This is the traditional territory of the Anishinaabe people, which include the Ottawa, Ojibwe, Potawatomi, collectively known as the Three Fires Confederacy, and the Wendat Nation Huron. So for the flow of today's events, we're going to shortly turn it over to our guests from Giga Metals for the feature presentation. This will be followed by a moderated Q&A, and then at the top of the hour, we're going to begin our lightning presentations by a few IRAP clients on their business models, businesses and technology solutions. Of course, I'd like to extend my thanks to IRAP. This technical symposium is made possible by the financial contribution from the mining sector team at NRC IRAP, the National Research Council Industrial Research Assistance Program. So if you would like to connect with NRC IRAP, please contact Peter Howell. You see his email address on the screen there, and Alexandra will put that into the chat as well. We have a number of great participants and organizations joining us today from right across the sector. So I want to extend a warm welcome to all of you and thank you for joining us. Now moving to our presentation. So for the presentation, I'm very pleased to be joined by our expert and a good friend of BMAC, who's worked very closely with us over the years and provided lots of great insight to our work. So Lyle Trytten is the Manager of Development at Giga Metals. Mr. Trytten has more than 25 years experience in the metals industry and is previously General Manager of Sustainability with Sherritt International Corporation at their Alberta Nickel Cobalt Refinery. In this role, his duties included oversight of EH&S, stakeholder relations, and emergency response programs. Previously, Lyle had managed Sherritt's metallurgical research and engineering groups and led project reviews for potential investment by Sherritt's technology division when it operated as Dynatech Corporation. In his later role, he was a member of the Ambitobi project due diligence and feasibility study teams, as well as reviewing over 100 projects across a wide range of commodities, including mining, processing, and recycling. Lyle has personally been involved in metallurgical operations on 5 continents. So Lyle, I'm going to turn it over to you.
Thanks very much, Sean. I'm just going to share my screen here. And we'll get rolling. And don't worry about stumbling over Ambatovi. There's one person on this call who can pronounce that properly, and it's not me. So, we will get going. So when we put this together, I wanted to think about where Canada's energy landscape is going. I'm in Alberta, oil country, and that's certainly Canada's energy currently. But as we go forward into an electrified revolution and we start to decrease the reliance on fossil fuels, we're going to see a different form of energy come to the forefront. And that's going to be driven by renewable energy sources and energy storage. And that's where Canada's minerals really come into play. So on the mining side, this is one of the reasons I want to talk about nickel as an energy mineral. It's not the dominant use for nickel today, but it will be a significant use as we go forward. Nickel's been identified as a critical material, critical mineral, depending how you want to think about those, in a number of jurisdictions, US, Canada, European Union, because it's key to a number of sectors of our economy. Electrification, electric vehicles and other batteries, the defense industries, stainless steel for infrastructure, long-lasting infrastructure. Those are all super important sectors of our economy, and nickel makes all of that possible. The chart on the right is something I put together to just give a super high-level overview of the major nickel processing routes used around the globe. I've got a set of white papers I published recently on LinkedIn. Feel free to connect with me and have a look at those on processing of nickel sulfides. They're in far more depth than I can go into today, but if you're interested in the topic, please feel free to have a read of those. What I want to go through today is just a high-level global overview where the nickel industry sits today, how that reflects in a Canadian overview, and where our what I call our energy advantage for the next several decades comes into play, and some of the supply issues that we see around the nickel business. As with most commodity businesses, it's cyclical. We're in a bit of turmoil right now in the industry, which is interesting times, as we often have. Globally, about 75% of nickel is used in stainless steel and high nickel alloys. These get used in everything from, infrastructure, the Chrysler building. It's used in rebar for concrete bridges. It's used in chemical plants, all sorts of things. And of course, the front of your dishwasher and your fridge and all your cutlery. That's a growing demand segment, about 2.5% compounded annual growth rate. It's going to continue to get bigger and need to be supplied. At the same time, we have the battery sector that has come from a very small use of nickel 5 or 10 years ago to being a significant use, over 10% today, with an amazing 13% compounded annual growth rate. That demand is going to become equal to the stainless steel demand in the coming decades. And that's a really important feature that we need to keep in mind, because that changes some of how we want to use nickel and some of the forms we want to produce it in. Today, nickel is sold in 3 finished forms: Class 1 or pure metallic nickel. This is nickel cathode, nickel briquettes, nickel powders. Class 2, which is impure nickel products like nickel iron alloys that are used to make stainless steel, and then chemical forms. And that's one of the growing market segments right now. Globally, there's 2 dominant mineral forms for nickel: oxide deposits, we call nickel laterites, and sulfide deposits. The majority of production and resources and production growth globally has been from laterites over the last 15 years. Today, we have about 3 to 3.5 million tons of global supply of nickel into the marketplace. More than half of that now comes from one country, Indonesia, almost all of as Class 2 nickel, almost all funded by Chinese money, building facilities there after Indonesia declared export bans on shipping ore to China for processing. We've seen a growth in Class 1 metallic supply from China in the recent couple of years. That's been leveraged by some relaxed rules on the London Metals Exchange around qualification of materials, but it is certainly a growing area of production in China. And overall, we've seen somewhere between 7 and 8% annual growth rate in supply over the last 8 years. It's been growing quickly, to the point that we're now in a surplus situation, which has really depressed prices over the last 6 to 12 months. The other large suppliers internationally, besides Indonesia and China, have all been suffering decreases in production. Russia's production is down, Japan's is down, Australia, Canada, they're all down. And these are, these 5 plus Indonesia really dominate the world nickel industry. Part of the reason is that there's no great projects out there. We all want to have that next great project that's got high grade, will last a long life, will make a high production rate in a great location. That'd be lovely, but exploration's a tricky business, and we haven't found a great new deposit in decades now. Most of the deposits that have been exploited in the last 15 years have been known since the 1960s. So that large supply increase in 2023 has created a lot of turmoil, and we now see some mines closing in some jurisdictions. That 2040 demand that I show there, 7.6 million tons. That's more than double what we have today, and it's going to be half batteries is the forecast. And that's already considering that a significant chunk of that battery supply in the world will not be nickel-based batteries. It will be iron-based batteries and others. In Canada, we used to be the globally dominant player in the nickel industries back in the 60s and 70s. The former Inco, which is now part of Vale and is being spun out as Vale Base Metals, stood for International Nickel Company because they were the International Nickel Company. We have nickel mines, smelters, and refineries, all producing Class 1 nickel. So the map of nickel in Canada as it stands today is shown here. I've included the Eagle mine in the US because the US nickel production is really small, and their forecast potential is very small, and really it's a side feature of the Canadian industry. The concentrate from Eagle is actually shipped into Sudbury and converted to Class 1 nickel there. One of the facilities in Canada ships that concentrate to China. All the rest, it's treated in Canada. One of our smelters exports intermediate products to Norway for refining to Class 1, but one of our refineries imports intermediates for production of Class 1 nickel. So we have an international trade in nickel concentrates and intermediates, as well as the final products. Over the years, we've seen production falling in Canada for a variety of reasons. There are, however, many new projects on the horizon with a range of characteristics, and some of these projects are reasonably advanced and have major partners. My work with Giga Metals, we have Mitsubishi Corporation from Japan as a partner, Outokumpu, Anglo-American, Agnico Eagle just bought into the nickel business, so as did Samsung. So we're seeing some life in the Canadian nickel projects, which is tremendously exciting. And we have a massive supply and resource advantage over the US. We have all the nickel processing, and we have most of the nickel resources. The US has some great resources in other metals like copper and lithium, but not in nickel. They've got very limited potential. And that's why I think about it as our energy advantage. In North America, we've got a huge and growing demand for batteries for electrification. The IRA has really spurred this on, but it was going long before the IRA. And the nickel avenue here is that nickel really is what gives the high energy density to the premier EV batteries. The nickel manganese cobalt batteries that are used in by many manufacturers, and the nickel cobalt aluminum, moving to nickel cobalt manganese aluminum batteries used by Tesla. We used to produce batteries at 33% nickel, one so-called 111 NMC batteries, 1 part nickel, 1 part manganese, 1 part cobalt. That's moved now to 5 parts nickel to 6 parts nickel. It's now moving up to 8 parts nickel, and they're now testing 9 parts nickel with 0.5 manganese and 0.5 cobalt. This is all driven by wanting to achieve higher energy density in these batteries. That's because in North America, range anxiety is a significant limiting factor, and especially in Canada with our vast northern landscapes. People are concerned about having vehicles that don't have a significant range, and other battery technologies such as LFP, LMO are still struggling to compete with nickel-based batteries on range. They're great for a commuter vehicle. I wouldn't mind having one for the driving that I do. I don't go long distances, but that is a concern for a lot of people. With all these new gigafactories that have been announced in the US and in Canada, as shown on the map here by CSE Energy Goon, the supply chain is really unresolved for most of these today. It's being worked on, but there is hope by the battery companies that they'll be able to achieve a supply chain independence from some of the Chinese suppliers. And there's certainly pressure on them from the IRA in the US to advantage alcohol production. Free trade countries like Canada, like the US, like Australia. Do you mute yourself, please? Some of the work that I've done suggests that, with a reasonable mix of LFP and nickel-based batteries in North America, we're going to need something like 250 to 450,000 tons per year of new nickel supply to feed the announced projects in North America. That's huge. That's 10 new large mines, plus the downstream processing to deal with those materials. What's the final number going to be? We can't know that today, but when we think about how many projects we need to bring on, it's kind of all of them. So Canadian nickel is really important in this space because Western EV buyers and therefore their manufacturers want to be fueling their vehicles with clean power, and they want their batteries to be made with clean materials, responsibly produced materials. This is why we've had a big fight over cobalt in the last several years, since some of the work by Amnesty International that revealed some issues with child labor and things like that in the DRC. There's been a lot of work done on that topic. What we see in the nickel industry is the primary concerns are around carbon emissions. Nickel production from laterite deposits is highly carbon emitting, and other ESG issues such as biodiversity, cutting down tropical rainforests, these kinds of things. The kinds of nickel deposits that we have in Canada have an inherent advantage. As sulfide projects, they are made of nickel sulfide minerals, and they have an inherently lower greenhouse gas intensity due to two main factors. One, the ore can be beneficiated. So you can take an ore body that's at 0.5% in the ground and process it through a fairly simple process using electrical power to produce a nickel concentrate that's 10 to 15% nickel. That nickel sulfide concentrate contains the sulfur, which when we treat the material becomes an energy source. And so we're not having to put as much energy in as when you use an oxide resource like the laterites, where the entire ore body needs to be processed either chemically or through melting in thermal furnaces. That's an incredibly energy intensive process. If we have mines and processing facilities that are hydropowered, or in Ontario with the nuclear power, these will be amongst the lowest greenhouse gas emitting projects on the face of the planet, and that's tremendously advantageous for us. Most of the newer supply that we've seen come on has been at the high end of the carbon curve, and Canada sits at the low end, and that's a big advantage when it comes to the EVs. Frankly, although nickel is nickel and everybody should care, nobody cares much about the greenhouse gas footprint of their stainless steel. I'd love to see it be so, but today it's not. But there is an investor movement, just like we saw consumer-driven movements around blood diamonds, around sweatshop production of clothing, Nike in the 1990s, and some other material issues. We're seeing a consumer movement around the sourcing of materials for EVs. As I said, domestic production has been falling. This is, fairly normal that mines deplete over time. We consume the best ore and we leave lower grade ores, or we deplete mines entirely. And then the mines are either closed or are, processed at lower grades, which reduces production, or they're renewed by finding additional resources in the area. But those additional resources are probably not as good as the ones that were originally being treated. We've had no significant processing capacity additions announced in decades. In fact, we've had capacity shrinkage at the Sudbury facilities through realignment of how the process works there. We've advanced several new mining projects from PEA into PFS, some through to full feasibility study. And we need these, but they're not enough to meet domestic demand. We need these and more. The problem is that exploration, finding new deposits and bringing them into production, is a very long-term play. It's on the order of decades. Most of the deposits that we're talking about perhaps putting into production today have been known for 30, 40, 50 years. They're only now getting talked about turning into mines. Mine financing is very challenging. Today, there's a market surplus. Junior markets that finance the exploration and development through to feasibility studies are struggling. And we have a catch-22 situation in Canada where if you were to bring a new mine on, where will the material go to be processed? But who's going to build a new refinery without new mines coming on to supply it? The synchronization of that is a key feature that needs to be looked at through industrial strategy, and certainly a feature of a number of discussions that I've had with various levels of government. Recycling is hugely important, and nickel is one of the most recycled materials on the planet. But the fact that it goes into very long life products, stainless steel lasts for many decades, batteries last 10 to 15 years or more in cars, and then they can have second life as grid storage, means that recycling is not the answer to battery production for at least 30 years. I think it's more like 50 years because the EV market is growing so quickly. Even when we get high return of batteries into the supply chain and have a full recycling supply chain, the market will have grown so much larger from the time those batteries were put into production that there's still a huge gap. These gigafactories that are getting built take a few years to build. They're relatively straightforward. Yes, they're massive multi-billion-dollar projects, but they're, the installation of them is not subject to the same kind of rigorous multi-year environmental studies that we see with new mining projects. So mines typically take a decade or more to bring into production from the time that you've gotten through the engineering studies at the front end to determine what will it produce and how much will it cost. And the reality in the nickel business is that every concentrate and every processing facility is different. And there's an open question out there as to whether there can be one solution, one solution to rule them all as we go forward that will treat all nickel materials produced in Canada. It's not clear that there is, but we also don't necessarily have to do what we've done in the past, which is everybody go their own way, build their own facility with their own design, however they choose, and subject to their own constraints and desires. There may be more synchronized routes to do that. On that processing side, the reality of the nickel sulfide world is that we have to deal with what's in the ground, and we all love Mother Nature when we go hiking and skiing and stuff. But she didn't leave us a whole bunch of easy to deal with deposits that are all the same and will produce the same product out of them that then gets the same processing. Every nickel deposit has its own unique characteristics, and those different feed mineralogies require different processing treatment stages. There are some commonalities for sure, and there are a lot of things that can get lumped together, but there are also significant differences between them in how the nickel is presented, the minerals it's in, what byproduct minerals are there, and what unvalued minerals, gangue minerals are there. We have multiple processing methods in Canada and globally, in the nickel business. If you want to understand how many ways there are to treat nickel sulfides, just count the number of facilities in the world, because it's pretty much one for every one. The smelting and refining facilities are all a little bit unique. There are other processing options available that are not yet widely adopted. They may be, but it's still uncertain because this is a risk-averse industry. I see some strong potential to integrate new material processing and recycling in one facility. The two aspects of the industry can really benefit each other in stabilizing refinery operations by creating a more consistent feed. But will that happen? Nobody's yet building those new facilities in order to take advantage of that potential, but people are talking about it. In Canada today, most of the nickel goes through smelting processes. So we take the ore, we beneficiate it to a concentrate, we ship it to a smelter. It gets smelted to make a nickel matte. That's a high temperature process where we melt the nickel concentrate. That matte then goes through a refining process to make nickel metal, and that nickel metal can go off to make batteries or stainless steel or other nickel alloys. We do have one facility treating nickel concentrate through a hydrometallurgical approach. That's Long Harbor in Newfoundland that Vale runs, that goes direct to nickel metal, skips the smelting and refining with a single stage process. It works, and there are other options for that hydrometallurgical processing route. What we haven't seen yet, but we might see, is that new facilities could skip the nickel metal production and go straight from the refining, whether it's pyrometallurgical through the smelting refining process or hydrometallurgical, and go directly into the battery supply chain without going through nickel metal on the way. It's entirely viable to do, has its pros and cons and challenges. So, will we see that? I think we will definitely see some of that get built in the future. Just touching briefly on the Turnagain project that Giga holds in partnership with Mitsubishi Corp as an example of the kinds of projects that we have in Canada. These are long life projects. This one, we're looking right now at 30 years with the defined mineral reserves that we have in the deposit. There's additional resources that may convert to reserves eventually, but that's where we are today at 37,000 tons a year of nickel plus cobalt, about 20 to 1 nickel to cobalt ratio. So, call it 33,000 tons per year or 35,000 tons per year of nickel. That's a very sizable project. That's competitive on the global stage as being thought of as a global scale project. Some of these newer projects like Turnagain are surface expressed. They are available at surface, which means that as you dig an open pit mine, you have a very low strip ratio. So this one is a 0.4 strip ratio, so 0.4 tons of waste per ton of nickel ore that you then treat through the process. And having a low strip ratio is hugely advantageous in terms of the cost of production and the amount of waste that you have to deal with, because mine wastes are a significant issue for the long term. We feature a very simple flow sheet. Crush the ore, grind the ore, and put it through a froth flotation circuit, well-established technology used throughout the nickel sulfide industry today, through the copper industry, through the zinc industry, at small to large scales. So very well understood processing, making a high grade, very standard concentrate, 18% nickel, a little bit of cobalt in there as a byproduct value, some iron sulfides in there as well, which help to provide the energy required when it goes to smelting or refining. Would fit into any existing nickel facility today, although maybe not as the sole feed because of some of the impurities that are in it. It may only make a portion of the feed to existing nickel smelters. New smelters could certainly be designed, or refineries that would treat it entirely as a standalone option. In BC, of course, we have strong ESG practices, hydroelectric power. We've adopted UNDRIP in regulation, so that gives a certain degree of certainty that the project only goes ahead with the consent of First Nations and avoids some of the big fights that we've seen in Canada over the last decades. And relatively easy access to deepwater Pacific ports at Stewart, 400 kilometers, which it was a long ways, but in terms that Canadians and Australians understand, or Russians, it's not that far. And it's all year port access. So we feel very good about many of those attributes. We're in discussions with our Tahltan and Cascadena nations in the area, who are both broadly supportive of mining. But of course, we'll have needs to be met on how the project proceeds, if it's to proceed. That's still a ways down the road as we work from our current PFS into a feasibility study stage. But we're, ourselves and Mitsubishi remain very positive about the prospects of this to supply Western products, Western batteries, whether the material gets refined in Canada or taken overseas for refining and shipped back to Canada. Those are both viable routes. There's no real preference for one or the other. So, I'll leave you with this thought. We've got a lot of gigafactories announced, a number that are starting to get constructed. Many or most of those will be wanting to produce nickel-based batteries. And where will that nickel come from? Certainly, some can come from Canada, and in the future more if we develop our assets. Some will come from free trade partners like Australia, but there is chaos in the Australian nickel industry this month with announced closures. What we, Canada and the US are focused on is trying to avoid some of the geopolitical issues that come with sourcing it all from a single nation that has a large degree of influence from a geopolitical rival. So, there's certainly a lot of thought and talk about how to incentivize Canadian nickel production. to make sure that we can feed the battery factories that are coming up. And I'll leave it there and open for questions.
That's great. Thanks very much, Lyle. Very informative as always. And I like the question that you ended on because that was going to be my question for you, actually. I was hoping you would have the answer. It sounds like production is down, demand is up. That's not a good scenario. But you talked about some of the facilities, the existing processing facilities that we had in Canada, that they've closed up or have reduced production. So is it, at least as a short-term solution, as simple as kind of turning some of those back on or increasing production at some of those, or do you really see this is going to need new development?
I really think it's going to need new development. What we've seen in Canada is, for example, the Thompson smelter closed because of restrictions around sulfur dioxide emissions. And it's not economic to make sulfuric acid in Thompson and ship it out to the world. So Vale redirected all of that concentrate into their existing facilities, but they realigned their facilities in Sudbury for more economic operation and reduced their smelter capacity somewhat. Can they restart? Perhaps. Will they? Hard to say. They've made the decisions they have for a reason. Other facilities, Long Harbor has not yet made its design rate. Maybe it will, maybe it won't. It's hard to say. The Sherritt refinery, Carefco refinery in Fort Saskatchewan, is struggling on having sufficient feed from its supplier in Cuba. So, where else are we going to do this? The Glencore facilities in Sudbury are doing well, but they don't have a ton more capacity, and they will have capacity for new concentrates as their existing concentrate sources dry up, but that doesn't help our total production. So we're definitely going to need new facilities. Canada has peaked at about 140,000 tons a year of nickel production in recent years. We're not going to get 200,000 tons additional out of what's only made 140. So lots of new facilities are required.
New facilities and new mines. So both ends, like you said, and synchronizing it.
Yeah.
All right, I'm going to turn it over now to our audience here for some of their questions. Of course, lots of information. I know there's probably a lot of questions that people have. You can either raise your hand using the reaction under the reaction tab on your screen, or type it into the chat, and Alexandra and I are going to keep a look for that. Alexandra, do we have anything so far?
Not yet. Everybody's been pretty quiet. So I'd encourage you to ask questions because Lyle is a font of information and a self-proclaimed nickel nerd. So it's fantastic that we have him here.
Let me just say, I'm not a self-proclaimed nickel nerd. I was
Oh.
branded that last year, and I thought, yeah, that's pretty much me. I am a nickel specialist, and I will own being a nerd, as those who know me will agree. But it's worked out for me.
It's good alliteration.
Yes.
Well, one thing
ahead.
that I would ask then, Lyle, is in terms of what you're seeing maybe potentially coming out of the market, you talked about a lot of potential things and new technological developments. Is there anything that's really getting you excited on the side of either a new processing technology, maybe something on the mining side that you think is going to really help or could help spur the development?
Well, absolutely. So there's two things that are exciting me right now. One, we've known about these large, low-grade ultramafic deposits like Turnagain, Lake Demont, Crawford, FPX, Baptiste project in Canada for a long time. Turnagain was discovered in the 50s. They've always been considered too low grade, uneconomic. They don't make sense. And there's always been significant questions about, can you actually produce out of them at the rate that people say you can? What we started to see in the last year or so is that we're getting much better definition on the ability of these projects to do what they will say. The geometallurgical work that we did at Turnagain in the last 2 years has been pretty foundational in giving us a lot of confidence in the reliability of production. We will know how much nickel we can produce from any given ton of ore based on its chemistry. We won't be guessing at it. That's hugely important for investor confidence. And we've seen now over the last 2 years, a lot of investor interest in these from major strategic players in the industry. You know, you can finance a junior exploration company off retail interest, but retail interest doesn't get you through the hard yards of development, where you're talking about tens of millions of dollars to do feasibility studies and environmental impact assessments. That takes strategic players. So having companies like Mitsubishi Corporation, like Outokumpu, like Anglo American, like Samsung, like Agnico Eagle, investing in these projects is a great vote of confidence that they have a future. And these are the biggest potential sources for mining on the North American landscape, right? These projects are all in the 40,000 ton per year range, and that's very significant. There's a lot of smaller projects that are maybe higher grade, but they'll produce 10 or 15,000 tons a year for maybe 10 years. Those don't answer the bell for providing, 50 years of increased supply. So on the mining side, hugely important steps in the last 2 years. On the processing side, I'm a hydromet guy by background. My experience is with Sherritt and marketing and developing Sherritt technologies around the world. And I know my ex-colleague Corey Kaczynski is on this call, and he's working in this space right now. There is definitely room to forego traditional smelting and refining, which might be challenging to permit a new smelter today, and go direct to hydrometallurgical refining of nickel concentrates to make feed for the battery supply chain. This is very doable. We know what the technology looks like. It's technology that's used widely within the gold industry today, refractory gold pressure oxidation facilities. It's being used within the zinc industry in Canada and elsewhere. There are options around it, but oxidative pressure leaching of nickel sulfide concentrates, totally doable. And I think we're going to see facilities built. And I think that's going to be the route that we take to the battery supply chain rather than building new smelters, because I think communities are going to resist smelters, even though they're really good processing answers and can be operated quite cleanly. They have a bad history over the last 100 years of contamination. The smelters of today are not like the smelters of 1920, but I think you will see resistance there. Hydromet facilities are inherently less polluting in terms of air and metallic dusts. And I think you will see, they have other challenges, but I think you'll see that being the technology of the future. And I look forward to seeing that developed in Canada.
So that last type of process you're talking about, this new technology, who's developing that type of stuff right now? Is it the industry doing it? Is that at like R&D stages within schools, academia? Is it a bit of both?
Well, the reality is that most of this technology has been well known for a long time. I was doing work on nickel concentrate pressure oxidation more than 20 years ago with Sherritt's technology arm. It's a matter of people being willing to invest to adopt it. And it isn't at the, this is not new stuff that needs university research. This is stuff that needs, we talk about research and development. This is now firmly into the development space. We understand the chemistry. We understand it at a research level. We now need to move into the development space. The problem we see is that the existing players in the nickel market, your Vales, your Glencores, these kinds of companies are reluctant to adopt new technology. They're not really pushing it forward. And so it needs new market entrants. So, we've seen some announcements in Canada recently. There's a company being backed by Kinterra Capital called Nyobolt that is now actively looking at developing an MHP facility, a nickel concentrate pressure leaching to make mixed hydroxide or other products in Canada. And that's a fantastic step forward. I think it's going to come from new market entrants, not from the existing companies, because I don't think they have the interest in doing something different. They like to do what they like to do, and they know well. And companies have been penalized in the past for doing new things because it hasn't always worked out well.
Well, it's interesting, and having new entrants come in to do that maybe is what's needed to fill that gap then, at least. So it's nice to see that there are some doing
Absolutely.
that.
Yes.
I want to pop in because we've got another, Ken's got his hand up, and we've got a couple questions in the chat. Just before we switch topics, we had a question from Liz, who says, "Hi, Lyle. What are the chances we see new hydromet facilities in Western Canada in the next decade?" I wanted to just touch base on that last point that you made before we.
Yeah, I think there's a significant opportunity to see new processing facilities in Western Canada in the next decade, but they would have to be paired with a resource. So is it going to be to process material from FPX Baptiste or from Turnagain? Quite likely. I think we'll also see some quite possibly some recycling develop in Western Canada. And that, as I alluded to in my presentation, there's an interesting pairing of fresh material treatment with recycling that can eliminate some of the issues that you face around dealing with either a straight recycling flow sheet or a straight fresh material flow sheet. So I definitely think there's strong opportunity for that, but it needs a champion. It needs somebody with the money to back it and to really push it forward. And that might be an existing player, but it might be a new entrant. So
I think you touched that's great. I think you touched on the recycling question that we've had a couple questions come up on. And just looking, what are those opportunities? And I think you touched on that in the presentation as well, that there's opportunities there, but probably just not enough and too far down the road. I mean, is there kind of a timing you see when recycling really will have a big impact?
Oh, I think it will have a big impact in 10 years. I think it will, but I don't think it will form the lion's share of the feed for battery factories for at least 30 years. And that's simply because of the pace of growth. If we had a stable situation where we were producing 10 million vehicles a year today, and we just switch them all to EVs, then in 15 years, all that material comes back and it makes the next 10 million vehicles. But because the EV industry itself is growing so rapidly, when you look 10 or 15 years out, your number of vehicles you're producing, the amount of battery capacity you're producing is 3, 4, 5 times higher than it is today. And so even if you get 100% recycling of the material that goes into batteries today, in 10 years, it's only a small component of that overall production. What you need is to top out the growth curve and get into that more asymptotic plateau at the top when most vehicles are EVs. And then 15 years from there, you're now going to start seeing the recycled materials being a significant proportion of the feed. Hugely important to do it. It's just not going to make all the new feed that we want in a circular economy framework for a long time yet.
Especially when demand keeps increasing all the time,
It's
right?
all about that. Yeah.
All right. I see Ken has his hand up. Ken, if you want to unmute yourself, you can ask your question.
Sure. Thanks, Sean. And thanks, Lyle, for that great presentation. And thanks, BMAC, for organizing this webinar. So, Lyle, I have a couple of questions. The first one is I was wondering if you were able to share any publicly available insights about that proposed power connection. Is the 1.505 federal government, the Critical Mineral Strategy Fund, going to be part of that proposed line? And the second question is, my colleagues who are based in the States and the Europe, they usually talk to potential investors. When it comes to nickel projects, Giga Metals and Turnagain project is one of the 2 projects we usually mention that are in BC. When it comes to ESG advantages, I was wondering if you're able to share any advantages that are specific to the Turnagain project that we can highlight to our potential investors.
Sure.
Thank you.
Yeah, so I'll take those in order. As far as the Canadian Minerals Infrastructure Fund goes, that $1.5 billion that the federal government has announced, that's hugely important because these projects require access to good infrastructure, whether that be both power, road, sometimes port facilities, are the typical infrastructure things that we see for major mining projects. Today, I don't think there's been any announcements of funding for specific projects, but we would expect that these are the types of projects that the fund is there to support. The government has indicated that, it looks like it's going to roll out over 5 years, the $1.5 billion with tranches of funding. So there will be, 2 different types of funding, projects for engineering studies and projects for development, that will have different, intake approaches and award approaches, but you're going to see it be phased over the announcements over 5 years. It's not going to get all announced right away. And so that gives time for projects. So, it would be premature today for Giga Metals, for example, to be lobbying for the money to be spent on that power line when we are not approaching a final investment decision. And we're not ready to build a line to nowhere. But there are other reasons to build an extension to the Northwest Transmission Line in BC, or indeed some other transmission lines in BC and around the country, to advantage other things as well, right? Whether it's other mining projects, communities, connecting energy sources, like we have some in the Yukon that would love to be connected to BC, those kinds of things. So I think you'll see that fund supporting a wide range of projects across Canada over the next 5 years. When it comes to the ESG characteristics, we have to remain aware that our approach to ESG is a bit of a double-edged sword. There are a lot of investors that think it's too hard to build things in Canada. It's too hard to get through the permitting process because we've demonstrated some great difficulties with some projects, like some of the pipelines and things over the last decade. But that fulsome permitting process gives a lot of certainty to strategic investors of the ESG credentials the project brings to bear. And when we think about projects in BC, indeed, there's really 3 main features that we point at. Number one, it's going to be low carbon. We have a great hydroelectric system in BC. It needs to be beefed up even more, as BC Hydro has announced a call for power to bring on additional renewable energy sources. Site C is great, but it's not going to fill the need when we convert everything to heat pumps and electric vehicles and expand industry. Whether we should be using all the power that's slated for LNG facilities or not is an interesting debate, but certainly as we go forward, we'll see that debate unfold. So low carbon is part of it for Turnagain and for the Baptiste project. And all these ultramafic projects in general share an interesting feature in that the tailings from them are reactive with carbon dioxide from the atmosphere and sequester CO2, and that lowers the carbon footprint even further. Might be a little, might be a lot. It's difficult to say, but being able to react directly with the CO2 from the atmosphere, it's a great feature. And when you think about the nickel space, the other feature that we really think is important is that you need to get your nickel from somewhere. And where is it going to be the least destructive, the least disruptive, the most well managed? And the environmental management systems in Canada are, amongst the best in the world. The programs that we run, such as Towards Sustainable Mining, the ICMM programs that get followed here, these are great systems for managing projects and managing impacts. Being in the boreal forest, yes, you're going to have to cut some trees, but it's a relatively low productivity forest compared to cutting down tropical rainforest. So, underground mines have an even smaller environmental footprint, right? So we have those in Sudbury, but most of the new deposits that we know about and seek to develop are going to be open pit deposits. But it's a relatively limited footprint because they're deep deposits that constrain how much area you end up taking up. So those are all positive attributes compared to some other nickel project types where you have shallow deposits and have to extend laterally as you go and clear a large area. So those are sort of the key features, Ken, when it comes to BC projects. I'd like to address Peter's comment about Vale's hydromet process, if I may. Would I have time for that, Alex?
Yep, please do.
Okay. So the hydromet process that they're using for Voisey's Bay Con at Long Harbor, you know, I will say I wouldn't have built that plant using that technology. It's a fine technology. It works. What they're trying to do there is use pressure oxidation to oxidize the sulfur, but not oxidize all of the sulfur to sulfate, and recover all of the energy value, but only go part way. And so they add chloride to the system, which has been known for decades to suppress the oxidation of sulfur and allow some of it to be converted into elemental sulfur. It's an elegant process, but it adds a lot of complications when you have chlorides floating around in all your processing streams. You know, you then end up with chloride in all your effluents, which, you know, if you're on the ocean, maybe you can dispose of those. But if you're inland, you don't want to be using chloride in things because you don't want it ending up in the water bodies. So the processes that we're talking about for treating concentrates are different than the Voisey's Bay process, which has a lot of similarities to the process that Cominco Engineering Services Limited was developing for many years, the Cecil process. So that chloride-assisted leaching, yes, it works, but it's very limited circumstances where you'd want to use that. I think for most of the newer Canadian deposits, you're really looking at leaching, at oxidizing all of the sulfur, and you don't need to use that kind of a process, and then you get away from some of the effluent issues that chlorides bring, and some of the issues that it also brings in terms of the materials of construction. You know, chlorides are fantastically active ions, but they like to destroy a lot of different types of metals. And once you've dealt with stress corrosion cracking caused by chlorides in stainless steel, you never forget what it looks like. You know, it is problematic, but the process works, right? Just not necessarily, you know, there was a multi-billion-dollar plant that is a lot more elaborate than it needs to be, but it was designed to produce class 1 metal of very high purity. That's not the product I would choose to produce today. If I want to go into the battery market, I wouldn't go through class 1 metal. I would go through chemical intermediates and process them more directly. And that simplifies the process plants quite dramatically compared to what they were forced to do at Voisey's Bay to make nickel, cobalt, and copper metallic products.
All right, thanks for that, Lyle. I think we've got time for a couple quick questions here. I did see a hand up, Brian. If you still have yours, just raise your hand again. Lyle may have addressed it though, so in the interim. Oh, I see Brian there.
Yeah, thanks,
Go
Sean. I
ahead.
appreciate that. This has been really interesting, Lyle. Thank you. A question for you, and just wanted to provide context first. It's not easy for government to get it right in terms of how to incentivize a whole, like just even part of an industry. So, you know, in defense of them, I acknowledge it's not easy. Things are constantly changing. However, the way in which, you know, the incentive programs have been deployed inevitably are a little bit more of an emphasis on the downstream side across Canada. But there's going to be great benefits associated with that. And that could create a demand pull for a lot of that upstream extraction and the midstream processing domestically within Canada. Any thoughts from your vantage point, Lyle, as to now that we've got it set up in such a way, do we have to retweak the incentive programs or provide emphasis on a different aspect of it? Or let's just say, is it just going to take some more time for some of these programs to roll out? We just have to be patient.
You know, I think Canada has done a pretty good job on its industrial strategy as it relates to this. You know, we're not the US. We can't just debt finance everything the way the US does. The IRA is a tremendous program, but you couldn't quite run something like that here. What they've done now, you know, there's sort of, I think of it as a three-pronged approach. Yes, they're starting to incentivize a lot of downstream demand pull, and that should, in due course, create pull for materials produced in Canada because they will have certain advantages. That's great, but it by itself isn't insufficient. The CMIF, the infrastructure fund, is important because one of the roadblocks to a lot of these new types of deposits is simply getting the infrastructure to them. It's easier in some jurisdictions than it is in northern Canada, where, you know, everything is hard. But they've also, we're still waiting for the full draft regulations to come out, but I think it's the Clean Technology Manufacturing Investment Tax Credit. One of the two tax credits that they've recently rolled out is deliberately focused or allows for the upstream mining end. And what that allows is effectively a tax credit that gets you some of your capital back up front early on. And that's, from an economic point of view, very impactful for decision-making on mining projects. Because this is public information, I can disclose, we looked at this in the Giga Turnagain PFS. And in fact, just because of the way the cash flow works, the math is always a little wonky. We expect the after-tax rate of return to, in fact, be higher than the before-tax rate of return because of the advancement of those tax credits. And that is a tremendous incentive for the project. If it was a 50% ROI project that was a slam dunk to do, they wouldn't be as useful. But when you're in the base metals space, you're typically playing with low margin projects that are more like utility scale investments. They'll last a long time, but they don't return 30%. They return 10 to 15%. And that's sort of utility scale investments, and you have to think about them that way. And so that tax credit upfront is actually very powerful, and we're quite in favor of it.
Thanks, Lyle. That's great.
All right, thanks, Brian. So real quick, Lyle, one last question for you, because this is, and we mentioned the names a couple times, Vale and Glencore, and this potential talk of some sort of merger of operations in the Sudbury region. Do you have thoughts on that? And what kind of impact would that have? And we don't have half an hour, right?
Yeah, no, I have a lot of thoughts. One, this is not new. This has been talked about since the 60s. Yes, it could have some synergies. I don't think it's actually likely to come to fruition. I think there is going to be a huge push against it by organized labor. These are union mines, because it will put all the power into one owner. And that could be pretty dramatic. And with the unions come other things. I think that there's going to be a lot of push against that merger. Yes, it could have meaningful synergies, but getting people to play together, the mining business is one of personalities, and I think it will be challenging to get Glencore and Vale to agree when Inco and Falconbridge couldn't agree on merging these kinds of things. Ultimately, if it provides synergies for those operators, well, that's great for shareholders, but it really doesn't do anything for the broader nickel landscape in Canada. In fact, it is probably negative, because if I wanted to bring a nickel concentrate to market today, I can negotiate with two companies. And when there's only one, I can't negotiate. And the backstory to that is the Sherritt refinery in Fort Saskatchewan, that was built in 1954, still operates today, was only built because Sherritt had a deposit in Manitoba that it wanted to develop. And Inco at the time said, "We're not interested in treating your concentrate. Go away." And so Sherritt went away, and they developed their own process and built their own plant. And that incentivized a whole new approach that has led to technology being deployed around the globe based on that. But that was the attitude of a dominant player in the industry. We have enough of our own. We don't need yours. Go away. What we need is more competition, not more monopoly.
Well said. That's excellent. As always, Lyle, thank you very much. It's always great to hear your insights and learn a little more, although, it's such a wide topic. I'm sure you could keep talking, right?
Read the white papers if you're interested.
And Alexander has provided those links, and we'll follow up with everybody on those as well. So
yeah.
Now we're going to turn it over to our IRAP client presentations. And for these, we're not going to have time for questions, unfortunately, but what we're going to be doing is the 5-minute lightning pitches. So I encourage anybody, if you have questions, you can reach out to the speakers afterwards, and we'll have some contact information. You can certainly reach out to Alexander or myself if you missed that information. So we're going to start off here with Super Ionics, and I'm going to welcome Mohammed. Mohammed, if you want to unmute yourself, and if you'd like to share your screen, you can do that as well.
Yeah, thank you very much. I will be sharing my screen. So I hope my screen is being shared successfully. Is it right? Okay. Thank you very much for this opportunity. My name is Mohammed Shoaib, and I am a researcher at University of Calgary, and I am also working as a CEO of our startup company, Super Ionics. So we are developing next generation liquid electrolytes for mostly for lithium-ion battery and sodium-ion batteries as well. So why batteries are important for Canadian context? If we see this, these two graphs or maps, we can see like since Canada is an island gas-rich country, so it is also a biggest greenhouse gases producer in Canada, and transportation sector follows. Transportation sector is the second largest greenhouse gas manufacturer producer in Canada. And if we see like in terms of provinces, since Alberta is rich in island gas, it also has the biggest portion in terms of greenhouse gas emission in Canada. So transportation sector revolution should be a priority in Canada if we want to reduce our GHG emissions. And the one of the move is like EV. Other possibilities are uh, hydrogen-based vehicles. So if we talk about EVs, Canada has almost all the required minerals uh, that are used in batteries. Uh, I have shown a couple of like popular chemistries for lithium-ion batteries. We can see like the currently dominating one is iron phosphate. Our people are mostly using NMCs, different ratios of nickel, magnesium, and cobalt. So right now, 811 chemistry is being dominant, but in future, it's likely that people would be developing another chemistry that has 9 portions of nickel in the transition metal layer. So if you see overall like lithium, iron, nickel, manganese, cobalt, graphite, carbon, aluminum, copper, these are the elements required for lithium-ion batteries. And Canada is a top 10 producer of nickel, cobalt, aluminum, and carbon. It's also like #2 in the world for global lithium-ion battery supply chain. But somehow we don't have several gigafactories in Canada, even though there are some announcements and some companies are picking up. So at Super Ionics, we are not building a gigafactory for lithium-ion batteries. We are actually developing technologies that can improve the performance of lithium-ion batteries. For example, the biggest challenges for the lithium-ion batteries are the safety, charging speed, or low temperature operation. And we have successfully developed an electrolyte that can alleviate these challenges. So the electrolyte that we have developed can work at really low temperatures. Its operating temperature window is -30 to +60. It's really long life. It don't catch fire, and its manufacturing process is simple. It can enable the fast charging and can deliver high power. And it's also cost effective. So it's not like upcoming solid state electrolyte, it's a liquid electrolyte. So it's quite compatible with the existing cathode materials and battery geometries. Here is some of the performance that of the batteries that has Super Ionics electrolyte. For example, in the blue curve, we can see the batteries with Super Ionics electrolyte can retain their capacity almost 94% after 2500 cycles, whereas the same battery with the commercial electrolyte would reach to 80% of its capacity after only 1,000 cycles. So for context, like 2,500 cycles means if we have a similar performing capacity, similar performing battery in Tesla Model 3, and if we consider its CPA mileage, so then this Tesla can easily go beyond 1 million miles with still having 90% of its initial mileage or the capacity. And these graphs show the fast charging capability and low temperature operation of the batteries containing superanics electrolyte. This low temperature operation is critical for EVs, and it has been an issue in recent weeks. Maybe you people have heard news, EV owners getting stuck in cold temperature at charging station. So superanics electrolyte can actually significantly improve the low temperature operation capabilities of lithium-ion batteries. So a brief overview of our company, Superanics. We started in 2021 when we also submitted our first IP. And in 2022, we got some funding from the University of Calgary. We are still inside the University of Calgary. In 2023, we actually started developing small samples of batteries and our electrolyte, and we have got the third-party validation testing from Novonix. Now we are at TRL level 5 and 6. In 2024, we plan to move ahead, and from lab scale, we want to go to pilot scale, where we want to run some scooters or electric cycles on the road to test the real life performance of the batteries. And since we have a strong background of other battery technologies, for example, solid state electrolytes and different cathode material, in future we want to diversify our portfolio, and we want to commercialize the solid state batteries as well. So right now we are looking for investment, partnership, some help in commercialization or co-development of technologies. So this was it for Superanics today in these 5 minutes. So if you have any questions, please, you can search Superanics in Google and you can reach us, and either you can connect me through the organization management. Thank you very much for your time.
All right. Thank you, Mohammed. And now I'm going to turn it over to Mike with Bay Minerals.
Okay, thank you. I'm just going to share my screen. Like, Mohammed, if you can get off the screen, or yeah. I can't quite, oh, there we go. Thank you. I'm going to walk you through what we do. So Bay Minerals is a mineral processing company, and we are a tailings technology. We upcycle mine waste. And our tagline is really, we transform yesterday's liabilities into tomorrow's resources. So we're a unique team. We've developed a clean technology and a business model to tackle a big problem, which is abandoned mine tailings and orphan resource waste. We have a focus on chrysotile mines. Our technology transforms environmental liabilities into sustainable and responsible resources. And our business model is a solution for commercializing waste value. So I'll go through some of our technical highlights and our business highlights, but we reduce pollution, we upcycle resource waste, we're a net zero carbon process. Our business model is a circular economy solution. We make sustainable or extract sustainable minerals, and we have a CO2 sequestration option on our stuff. But when we go through this, we look at the problem, and orphan mine tailings are really a pollution issue. In Canada, there's more than 11,000 orphan abandoned legacy mines. And crystal mining has been one of the biggest, and it was large-scale mining for decades, and they orphaned mountains of tailings. And the crystal tailings are some of the world's largest dry stacked mine waste tailings. There's a couple pictures here of mine stacked tailings from crystal mines. Two of them are in Quebec, and one of them is in Bayvert, Newfoundland, and that's where we're focused. The problem with this is that there's been limited technologies to clean it up because it's classified as toxic waste, and the remediation costs have not been justified, and they're all in at this abandonment status. So our solution is, we take mine waste and we extract sustainable minerals. The tailings represent a low-cost, low-risk supply of already mined and available feedstock, and they have high concentrations of industrial and critical minerals. So our technology is a solution for reclamation, reducing, repurposing, recover, recycle, reuse. And basically, we have a high extraction rate with a net zero waste process. The big work engine on this is really industrial minerals. We get a lot of magnesium-based products, silica, and all the waste products would really go in and qualify as cement materials. Our byproduct, though, is we have critical minerals. We have nickel and cobalt as a byproduct. We're a circular economy business model. We take crystal mine waste. We have an extractive technology that is a pollution reduction process. Includes environmental benefits on one side of the circle. On the other side are the economic benefits. We extract industrial minerals, critical minerals, magnesium oxide, precipitated silica, nickel sulfate, and they go into sustainable industries, construction materials, fertilizer space, green tires, where the silica goes, and with green batteries, because we have a recycled, repurposed material. So we all qualify as a circular economy eligible material. And we have sustainable benefits. We improve health and safety by reducing the pollution. Our process is a four-stage process. It's proprietary and patent pending. We have proprietary preparation where we destroy the fibers that are in the material through an ultrasonic milling process. We take it through a dissolution process that totally destroys the crystal, an extraction process for the industrial minerals, magnesium oxide, precipitated silica, and the recovery stage, we get nickel and cobalt as a byproduct coming out of it. So what we've done is we've created a business model to make money from mine waste. It's a for-purpose, for-profit business model. The technology is ready. We've taken it to a TRL level 6. We're going to a pilot stage. It's a solution for pollution. It's a viable commercial model for waste to value as a profitable business. The timing is really good because the market's ready for a product like this. It's a robust business model, a strong customer demand, favorable legislation to address pollution. But importantly, this resource is ready. It's mine waste, it's low cost, it's low risk, it's available on surface. We have a strategic location and a potential to create a world scale resource. So we take our technology, we clean up pollution, and we upcycle resources and we make money doing it. So that's kind of my lightning pitch, and I'll just stop. If anybody wants any questions, we're on a website. You can contact us, through the contact information there. Thank you.
All right, thanks very much, Mike. Appreciate that. And very interesting technology. So we're going to move on now to our last presenter, Arthi. Are you there?
Yes. So I'll
like to
just
share your slides, please feel
screen.
free.
Yep. Hope it's visible. Yeah. Okay. Hello, everyone. First, I would like to thank Battery Metals Association Canada for the opportunity to pitch our technology to a wider audience. So I'm Arthi, a postdoctoral researcher from University of Calgary, and also a CEO of the technology startup company named Peach Tacury, So which is the practical electrochemical air capture and hydrogen, a direct air or ocean capture technology. So this speech technology is being developed by a transdisciplinary expertise from electrochemistry, geochemistry, engineering, and also law to handle the legal and regulatory issues during our deployment. So I'm here to introduce our technology, which uses the battery electrochemistry to safely remove and store atmospheric carbon dioxide as bicarbonates in the ocean. So according to the international, sorry, it's not moving. Yeah. So according to the International Energy Agency, the current carbon capture and removal technologies were estimated to remove only 300 million tons of CO2 from the atmosphere by 2030. But to achieve the net zero target, we need to remove gigatons of CO2 from the atmosphere. So there exist several carbon removal technologies categorized into land-based approach, such as like biomass carbon capture or the direct air capture technology, and the ocean-based approach like mineral addition to the ocean or the electrochemical process of electrolysis to enhance the alkalinity of the ocean. But these commercial CDR technologies still suffer from high cost of deployment, site-specific operation, and also the gigaton scale development. This is where our peach technology comes in. So whereas the peach technology uses a unique electrochemical approach similar to the seawater battery with an ion selective electrode to move the ions using the seawater as an electrolyte. So for example, we can say we alter the ion concentration using a sodium ion selective electrode, which is a battery material within the different regions of ocean, which results in the generation of alkaline seawater. So this alkaline seawater, when released to the surface ocean, it enhances the intake of atmospheric CO2. This CO2 gets converted into bicarbonate ions, which has a lifetime of 10,000 plus years in the ocean. So this is our lab proof of concept demonstrated with the pH increase in the seawater electrolyte. So thus we use these battery materials for the specific electrochemical carbon removal application, which can be installed in the ocean for ocean alkalinity enhancement or any land-based process which involves processing of brine solution. So this chart here shows the critical minerals list of Canada, and our electrochemical cell uses certain materials that are important for the battery applications like nickel, manganese, magnesium, and graphite for our carbon removal application. So thus, in comparison to other electrochemical CDR technologies, our peach technology is a non-membrane technology with a flexible design module adapted to work both on land as well as the ocean. So making it feasible to deploy at gigaton scale level. So finally, these are the milestones that we have achieved so far with the patent filing and incorporation of our startup company with a lab proof of concept. And to move forward, we will be developing a staged modules from 1 ton to 1 megaton by 2033 to play a major role in Canada's net zero target. Thank you for your time. And for further questions and engaging discussions, please email at us the given ID. Thank you.
All right, thank you very much, Aarti. And thank you to all of our pitchers today and providing their business pitch. Again, if you didn't get anybody's information, please feel free to reach out to myself or Alexandra, and we're happy to connect you. So before we close, just wanted to let you know that BMAC does have a variety of resources available on our website that you may find useful in better understanding Canada's battery value chain. So first here is our interactive battery ecosystem map, which you see on the left side of your screen. It's our second version of the map, and if you haven't looked at it yet, I encourage you to take a look at it. Go in there, search, and play around with the interactivity and learn a little bit more about who's operating the Canadian battery space. And just to let you know that we're working on the third version already. We have some new views coming in, some additional data points that we'll be adding as well. So look for that coming soon. And of course, if you're not listed on the map, then please let us know, contact us, and we can get your information on there too. We're also going to be working soon on some work looking at potential opportunities for battery hubs within the West, Western Canada. And so we're going to be kicking that work off soon. And that's really in follow-up to some of the work that we did on the roadmap report, which is also available on the website. So if you have interest in that, any questions, you'd like to get involved, please reach out to myself or Alexander anytime. And we look forward to working with everybody. So with that, I want to thank everybody for joining us today. Our partners, NRC IRAP again, and Lyle, so much for all the information in that presentation. So thank you, everybody. Enjoy your day.